Go.
Hello, welcome to the web conference, and thank you all for this morning's panel. I'm here today with a panel of experts, and I'll let you each introduce yourself. Tim, shall we start with you?
Tim Berners-Lee, inventor of the web. I'm at MIT and Oxford University, started the Web Consortium, Web Foundation, and Points West.
Rohi Sarakaya. Rohi Sarakaya, Director of Applied Science, Amazon Alexa. I'm based in Seattle.
I'm Wendy Hall. Excuse me, I'm Wendy Hall. I'm Professor at Computer Science, University of Southampton. I'm Chair of IW3C2 that organises these conference series, and I'm also Managing Director of the Web Science Trust.
Hello, Antoine Borde. I'm doing AI research, and I'm directing the lab of Facebook AI research in Paris.
I'm Radinsky. I'm the Director of Data Science in eBay. I'm also the Chief Scientist of eBay in Israel, and I also hold an academic position in Technion in Israel.
My name is Vinton Cerf. I'm Vice President and Chief Internet Evangelist at Google and the co-inventor of the Internet.
Well, thank you all for being here. And I'd like to open up the discussion from this morning's panel, where we talked a lot about personal data, and we talked about the sharing of data, the value of data. But I also wanted to talk about the value of prediction and the cost of prediction. So maybe we can start by discussing this.
Well, I'll just jump in, and Rui is elevating himself out of the chair there. Would you prefer to start? Go ahead.
I can give some color to it. I think the one concrete example of that is if you look at the medical field again, and people who are looking at MRI images, these are radiologists, and that's actually a very repeatable task, and the machines are getting a lot better than the human radiologists. And because you can, there are samples that you need to show to the machine, there's whether this person has certain type of disease or cancer or whatever. That's what humans does. That's what the doctors do. You can actually teach the machines by showing them examples, positive examples of, if you see this image, this is this should be this. They learn this mapping very effectively, even discovering the structures that the humans may miss. What does this mean is, we may not need radiologists 10 years, 5 years down the road, or not as many radiologists. That's one thing. The other thing is, there are other parts of the world where we don't have as many doctors in general. You can actually provide medicine to communities where they don't have access to doctors. So those are two huge impacts on society.
Kira?
I'll go with what very close to my heart, science. We scientists are very used to a very specific scientific way. We think about an hypothesis, and then we test it for 3-5 years. For example, in drug discovery, we could check a molecule, then it takes $12 billion, 15 years to make sure that it actually works. I'm thinking about reversing this paradigm using artificial intelligence. Can we have an artificial intelligence system that thinks about thousands of hypotheses a second, make sure that statistically they're valid, make sure the integrity of the data is correct, and reach a groundbreaking, maybe Nobel Prize winning hypothesis? Can we automate the scientist? I think this is where we're going to have a really good, scalable way of making discoveries that are going to change the world.
So I have an example to offer you, and I'd like to hear what your reaction is to this. One of our engineers at Google analyzed a great deal of data coming from some of the telescopes in order to detect planets that were circling distant suns. And he had a hypothesis about what signal could be extracted, a very, very weak signal could be extracted from that. So the system was not inventing hypotheses in the way that you were suggesting, but it was certainly exercising this hypothesis against a huge amount of data. And so I would argue that this is an example of the power of prediction where it's not just the data, but it's the way in which you choose to look at it, the way in which our automated systems can analyze it. So I care a great deal about the tools as well as the data that animate them.
Yeah. So if I can add something to what has been said, is like, I think there is the prediction, the power of the prediction, and who's using them, and I think we should really aiming towards like really collaboration between humans and people using the system that are performing the prediction, and this coexistence is going to go a long way, I think. So maybe for radiology, for instance, yes, the exams might be faster, the MRI could actually get quicker through AI, we could actually see through more exams in a day, but you keep the radiologist to be with the patient, explain what's going on, explain the implication, try to guide through basically the process of the drug, etc. So I think there is really this coexistence between humans and machine that's going to be very interesting in the future, and that we are to be very proud of.
I'd like to challenge the word prediction. I think in some areas you can think about predicting because you're talking maybe about exact sciences. But as Luciano said yesterday in his keynote, these things get very complex very quickly when everything's interacting. And when you're dealing with anything to do with people, prediction is really hard on it for what individuals are going to do. And when we talk about, say, the weather, we don't talk really about prediction, we talk about forecasting. And I think we have to be very sensitive to the fact that we won't, AI will not be able to predict with any certainty in many areas, and we should be thinking more about different scenarios of what might happen and forecasting if you have anything to do with human behavior, as we have in the social networks, it's about forecasting rather than prediction, would be my point here.
So I'd like to jump in and make a related observation, and that is that whenever you build mechanisms to do whether prediction or forecasting, one of the things you need to take into account is it might be wrong.
Oh, yes.
And the worry I have is that people will rely too much on some of these algorithms and assume, well, the computer did it, it must be right. That's something we need to guard against.
Yes, absolutely.
Of course, there's different ways in which things can be wrong. Things can be wrong because they haven't got all the data, or things can be wrong because the science wasn't very good. Things can be wrong because there's an assumption that every day is going to be like today, and in fact the system is unstable. So, for example, the financial system, the banks say, oh yeah, with the current regulation and with all of our knobs set exactly where they are at the moment, we'll all be fine. The financial system, we will all wake up each morning and people will be trading on the stock market. But every now and again, actually, there's a crash. You wake up in the morning and you find that the stock market has crashed. Every now and again, through history, people have woken up and realized that there's a social movement in their country which had taken them by surprise and suddenly spread because they realize that people, when they're angry, get together and they behave in different ways, and if you wish, society can be unstable. The power system can be unstable. We'll find out to what extent the weather, the climate can be unstable as we're pushing global warming, and now we're seeing things become more and more dramatic, record cold, record hot, and so on. Then one of the tricky things about that area, that space, is not just about predicting the average temperature on the Earth. It's realizing that the swings are going to be bigger, and maybe we will go into space where we will get very dramatic instability. So among all the systems that could be unstable, we have to worry about things being unstable. The system of social networks, the system of people connected through their social networks, seems to be one of the things to be where we need to be most concerned.
I want to get back to the point you mentioned. Specifically in healthcare, they talk a lot about the fact that if they have diagnosis tools, doctors will forget how to make diagnosis. And they raised a very interesting question. Would I prefer a doctor that's already seen many patients but without an AI machine, or a young doctor that didn't see many patients but with an AI machine? I think the entire question is wrong. It's like asking if I want to talk to a cardiologist with an EKG machine or without it. And this is where I really agree that we need to think about AI tools not as the ultimate prediction power that's going to do everything for us, but as decision support tools. And again, think about human-machine markets that work together and understand how we should work together. This is where explainability of the models is super important.
I think that point of decision support tools is a super interesting one, because I think that a lot of the tools that all of you are working on and the systems you're working on, they're support tools. And there's not, and I think the panic of that they're taking over this image that can sometimes frighten, people about the future is maybe a bit twisted.
I think that we will see increasingly people gaming this space. We talk about fake news, and I think that people will claim to be AI and be able to do very intelligent things when they really can't. You've already seen companies jump on the AI bandwagon, say what we're doing is AI, when actually, it's far from it. And there'll be a lot of misinformation about this.
Do you remember, well, maybe you're too young for this, but there was a little black ball thing with random answers in it, and you would ask a question and rotate the little black ball, and it would float up with an answer. You could claim that this is artificial intelligence, but it's not.
Well, thank you all very much.
Oh, is that it?
We could keep going on. I would like to close on giving you each a moment to give us maybe a forecast, something that you hope to see in the future.
Okay, I'll be happy to start. Let me say that science is successive approximation. And so the more data that we gather and the more we are able to find correlations, perhaps at some point we will actually find causality. And at the point where we find causality, we can find prediction. So we may actually refine our way towards something beyond forecasting.
I'll emphasize the same point. I really much agree about this. Working on correlations alone and statistical methods is not enough. This is not going to bring us to the next level. Understanding causality, understanding the processes, the mechanisms, just like we do in natural sciences, is the core for good predictions, which are understandable and we can work on.
Thank you. I think something I would like to see is that that everybody, or as much people as possible, are taking the AI train, the AI bandwagon, for the good reasons. So you talked a bit about the new companies saying that they do AI, even though they might not be. If people are educated, if the investors are educated, if the regulator, if the policymakers are educated about what AI is capable of doing, I think we could actually be a bit more conscious about everything that's happening.
Doing AI when they're not, companies will say that it's not AI when it is. But the point I'd like to make, I'd like to pick up on what the Secretary of State said earlier, diversity. If we don't work on that now, and it's the face of it, the big thing's gender, but actually it's also age, ethnicity, culture, disability. We absolutely have to have interdisciplinary teams working in AI with representing all the different sectors of society. And if we don't do that, then we are heading into a very space I really wouldn't want to see the world in. So my big vision is that in 10 years' time, we'll see a much more diverse, say 10, because at the moment we're going backwards, it's getting worse rather than better. And I would like to see a much more diverse workforce and a true understanding through education of how the world deals with the future with AI.
Two things. One is people who are actually in this field and doing work, they're the ones who are least worried about singularity, machine taking over. We're tens of years away from that reality. So I'm not actually worried about that. I see a positive in AI bringing a lot of goodness to society. Yes, there are risks, that we need to be mindful and addressing issues, diversity, bias, things like that. But overall, I think there are a lot of new possibilities on the way. I'm hopeful about that.
I think Kieran made a good point about clinical data, medical data. So in general, medical discoveries are coming faster and faster, but there's still a lot of things that we have a huge amount of work to do. I'd like to. You want us to look. What would I like to see? I would like to see a world where, by default, even though people have control of their own data and they have all their access to all their own health history data, maybe also their lifestyle data, like their fitness data and so on, that there's a convention where they make it all available, anonymized, so that the medical profession and the scientists have access to it, so that we have a very efficient way for scientists of getting at protein data and gene data, which is all public, but also all the very private data, which has been anonymized to protect people, or is used very by scientists in a very responsible way, so that if somebody says that they are going to use it for research purposes, we need to understand that they will only use it for research purposes, because the things, that's a really important path, because the things which have been happening, which we've already managed to achieve, and the things that we hope in the future to be able to achieve using that data which people have given for research purposes, are so exciting in the medical field.
Well, thank you all, and I really could continue the conversation, because having the absolute honor of being in the company of such great brains of this industry and great people of this industry. So thank you all very much, and enjoy the rest of the conference.
Thank you.
Thank you.
Thanks.